Alright, so what I got here is I'm going to put together a little video to show you how to tell, if you will, like 3-axis versus 4-axis versus 5-axis machining to kind of help you give you an idea of what customers will be better suited for what, depending on their machines and their capabilities. So what I have here is I have what we did on our 3-axis machine. This is technically a 4-axis part, but we work closely with the engineer team on this, so we negated the use of this feature right here, this circular feature, and I'll show you why in a bit. So I'm going to run you through the simulation of the making of this part. So we probed it, did our thing. Now, if you notice, everything is in one axis. So we cut it, and that was it. And that was done. And then to do the back side, all we had to do was come in with a flat tool and just face it off flat, right? The length. Now you can see here that that feature isn't in the simulated program, and the customer was like, "Oh, hey, if you can, they didn't mind because it saved them money, and it was their engineering team I was working with." But generally, to get that, we would either have to use a ball mill and come in and mill this like a 3D feature, so the machine would go up and down to that from this axis, like this, facing this way, like everything else. Or we'd have to put it on a 4th axis and rotate the part this way and come in and cut like that, which would have been the fastest way, but it saved the customer. That would have been 2 extra setups on a 3-axis machine to cut this that way, and then we'd flip the part and cut this that way. So without those features, this is 2 operations, and it's relatively quick. It takes less than 5 minutes to make this part. Moving on, this on the other hand is a 5-axis part, so I didn't do this one, but the customer had me look at it. So what we would have to do is we'd have to do one op this way, or this way, depending on how we did it. So we'd cut this profile, cut those, make all this pocket. But where it becomes difficult is this is one op. If we look at it like this, we'd have to flip it around, or vice versa. So one op, 2 operations to cut all this, and then there's a 3rd, and then because this is at a weird angle, that would make a 4th. And it takes time to load the machine and put it in 4 different positions. So I mean, this optimally would be done on a 5-axis machine because there's more than 2 or 3. There's multiple angles that we have to get at, and we can't get on it. We could do it on a 3-axis machine, but it would take a ridiculous amount of setups, and that would add time and money to the part. So we just referred them to a 5-axis shop that could do these parts a lot faster and a lot cheaper than we could. Here's a good example of a 3-axis part. It's very simple, right? We come in, we take the billet, we machine all this out, machine these pockets, flip the part over, and face it, and it's done. And those are the kind of jobs that we are, I guess, best suited for. So with this, setup time for the first operation ever is going to take probably 15 minutes to 30 minutes. And ordering material, it's relatively easy material to order. And then after the part is made, the part is really fast to make because it's literally profiling this out, pocketing, these holes with an end mill, flipping it over in one jaw, and facing it off. So lead time on like this kind of part I feel really confident saying that, it takes, for us, it takes 4 days, 4 to 5 days to get material. It'll take less than that to, we'll have the machine practically set up before the material even gets in, and then we just cut it. So it's less than 2 weeks to get like a first part out and get it into the customer's hand. Here's a different one. So this one, the customer provided us the poly box, and they're like, we just want these holes cut out. So it was a very easy 3-axis job where they asked for one with just one hole. So you can see it just came in and it was done. This is a little different. This is an in-house project that we're working on with some people, and this is optimally done on a 4-axis or a 5-axis machine. And the reason is that because for us to do it on the 3-axis, we'd have to set it up like this, 3D surface these weird angles, so that would take a little bit of time, and then we'd have to flip the part again to machine surface these angles, like this angle here. We're just on this part, we're just doing the general profile. They're handing us the whole slide. That's operational. We just are making these cosmetic features. So we do 1, 2, and 3, and then this over here would take some 3D surfacing that we'd have to do from this side. So it'd be 4 setups in our machine. Where in a 4-axis, it would only take like 2 to 1 setup, depending, definitely 1, because you could, with a 4-axis, you can do weird things like set up on an angle. Set up on an angle and make this part. Here is a great example of a 4-axis part, right? So originally the stock would come in an extrusion, and it would look like this. And what you do is you'd set up on the 4th axis. Well, we could do it on a 3-axis, but I'll show you why it's not profitable to do so. So on a 3-axis, we have to set up, do one side, machine all these features. That's one setup. Come in, do another setup at this angle to get these holes, these pockets, and to face this. Another setup, another setup, another setup, and another setup here. And another, so you get the idea. For every feature, there's a setup, or a side that we need to reach, there's a setup. Whereas on a 4th axis, the machine will rotate around the center, and you can get all of this in one setup. Here is a good example of what should be like a 5-axis or a 4-axis part. So customer right now is doing this on a 4-axis machine. So they come in, they machine all this on the 4-axis, they flip, do all this, do all this on the 4-axis, and then they machine most of this out, and then they put it in a fixture that drills that hole, and then they fix it up. So on a 4-axis, I think they're doing all this in 3D surfacing. So in this pocket on the 4-axis, so that's, well, I guess there's an extra setup right here, but it gives you an idea of the setups involved. This is a perfect 3-axis machine part. It's very simple. We start here, pocket, chamfer. We have chamfer tools, face, flip it over, face it, and you're done. So this is the good example of the stuff that we could just, again, have out in 2 weeks. This is another good example of a 3-axis part. So we'd start from here, profile all this, drill, 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 drill. This slot right here we can get with a key cutter. So we run the tool This way, and it would come in and cut the side out like that in a 3-axis, and then we flip the part over, base it, and be done. Same thing here. This is a 3-axis part. Right, we can do this side first. Pocket stuff here. Flip it over. Do these with a chamfer tool. Mill them and be done. Anyways, yeah, that's kind of an introduction to the stuff. We'll go back and look at, the 5-axis part has multiple weird angles to hit and stuff, and then let's see, where's that 4-axis part? Here, right? The 4-axis part has a lot all around the center of the part. So these things right here are what we can get out. The 3-axis, very simple. They're kind of, I consider them 2-dimensional. They're not 2-dimensional, they have depth to them, but everything can be, I guess everything on a 3-axis is a straight shoot, right? So there's no, we can do draft angles in here, but it's relatively, everything's straight to look at. Right, there's nothing, there's no holes here, there's no features that go into the part here on the side. It's just 1 and 2. In here, this would turn into a 4-axis if there was some weird, like, I'll show you. Let's say there was something like that, that would turn into a 4-axis part. Or it could be done on 3-axis. Like this is simple enough to where what we do is we do 1, 2, and then we just set it up in a 3rd vise and poke that hole out. But it gives you an idea of, that extra setup adds time and it adds a little bit of money to the cost, but it's not as much as if there's a lot of side features. In there. Same thing with here. Anyways, I hope this is helpful for you. Gives you a little idea of what I look at when I look at a part. Anyways, hope you enjoyed the video.